All right, hello everybody. This is, let's see, this is period 8. I'm doing number 6 here. I'm doing assignment number 6. All right, this is more modeling relationships to the line. I'm doing these videos to help people get caught up. We are looking at residuals, right? I can use residuals to evaluate the accuracy of predictions based on the line of fit. So here's kind of the reminder of how this works. Right? If you have all 6 of these graphs are residual plots. All right, all 6 are residual plots. 2 of these residual plots show that the model is appropriate, and 4 of these show that the model is not appropriate. Let's take a look. This one here, right? I have this red line is my model, and the data is scattered all along my model. I don't see any pattern. Therefore, I can see that the data is going along with my model. I mean, it may not be exactly on the red line all the time, but in general, my data is going at least in the same direction as my model is going, right? And I know this because it's scattered. This is another situation. Now, some people might get confused. This does look like a pattern, and it kind of is a pattern, right? There's something going on here, but notice how the pattern makes it equal on both sides of the line, and it's increasing, kind of widening at the same time on both sides. So this actually does show that at least my data is still going in the same direction as my model. My model is becoming less predictive over time as the data disperses, but that's okay. At least my model is going in the same general direction as my data, and that's a good thing. So model appropriate, model appropriate. Let's take a look at this one now. This red line is my model. This cloud of points is my data. My red line is not going in the same direction as my cloud of dots, which means my model is not appropriate. Whatever line I'm using here, it is not going through where the data is, right? It's not working. I need to try something else. Okay, this is a typical example right here, right? I get this U shape. This U shape tells me that there is a problem here. There's a problem here. My red line is my model, and the data starts below my red line, and then goes above my red line, and comes back down and goes below. This tells me that there's something else going on. That whatever model I'm using is not a good shape for the direction of my data. My data is taking a different shape than my model, therefore not an appropriate fit. My model is not appropriate because my data is showing me a pattern which indicates that the data is going in a slightly different shape or direction than my model. Here's another one. It's all my points are below the line in the beginning, and then they're all above my line in the end. That doesn't work. That's kind of like this one here, right? My data is going in a different direction than my model. My model is not inappropriate. And then here I still have that U shape going on, right? This is still a U shape going on where I have almost all my points are below the model in the beginning, and then it increases to where most of my points are above the model. But this U shape that I'm getting means there's probably something else going on. Another model that would be a better fit here. All right, and so this was calculating residuals. Let me kind of show you how we did this, right? We turned on our calculator. We did our calculator hygiene. Second, 7, 1, 2. Oops, I didn't do it. Let me try again. Second, 7. Nope, I'm missing a piece. I'm missing it. Sorry, second plus. 7, 1, 2. All right, that resets my calculator. Show it one more time. Second plus 7, 1, 2. All right, my calculator's been cleared. I'm now going to turn on the stat plot, right? I'm just going to do it. Second, see how it says stat plot in blue? Hit the y equals button, gives me this menu here, and I press enter to make this work. Enter, and now the stat plot is on. Life is good. And here's, we're not going to use the R value here today. The correlation coefficient not going to be used, but if you wanted it, you press the mode button. You go up and you make sure you turn stat diagnostics on. Right, I press enter. Now diagnostics would be on. Okay, my calculator is now ready for use. It has been cleaned and ready for use. I'm going to enter this data into my calculator. I'm going to do this kind of fast because I'm not have to wait for you at home. I'm just trying to show you. Here's how we did this. 26.94, 27.79. Oops. Nope, I don't want that. Stop, clear. Oh no, I got out of it. Enter, stat, enter. Right, okay, let's try this one more time. 27.79, enter. 30.12. 30.12. There we go. Much better. See, I'm trying to go fast, and it's just not working for me. I should not try to go so fast. Okay. 0.3. I should slow down, and that way it'll be more accurate. Good. All right, and then I got my data in my calculator. Now I'm going to do a linear regression, right? Stat, calc, go down to reg, linear regression. This will give me a model. This will give me a line of best fit. Y equals A times X plus B. I stick in, it tells me what A is, tells me that's negative 1.5, around 3, rounded to the nearest hundredths. And I see some of my data here is in hundredths, so I can use that as a, and then as a guide for where I should round to. And then 78, I'm not sure why we took this out to so many digits, 78.6217. If I round to the, let's see, what is this, the 10,000th place that I'm rounding to over here? Yeah, I don't remember why we took that out to so many digits. Probably shouldn't have given significant figures, but okay. All right. Okay, let me get rid of this little toolbar there. Okay. So we use this model to make some predictions, right? It says we will calculate the residuals for the 5 points. Will the residual for the car whose curb weight is 25.33 be positive or negative? So let's calculate the residual. Define the residual. Need to use this formula that I have. I need to use this formula. I'm copying it, and then I'm going to maybe paste it over here. There we go. Paste it where I can see it maybe. There we go. Good. I'm going to go to quit, right? I'm going to put in the formula, negative 1.53. That's my slope. It's a negative. It's going down over time. The car that's 25.33, right? 25.33. That's not point. 25.33. There we go. Plus 78.6217. What is the predicted value for this? The predicted value is 39.8. Looks like we rounded the nearest one here. Interesting choice. Okay, I see why, because we have the singles rounding the nearest units over here as well. So 39.8, we rounded to about 40. The actual was 43. How do we know that? There's the car that had a curb weight of 25.33, and its actual fuel efficiency was 43 mpg. The model predicts 40. The actual is 43. The residual is the actual, right? The observed minus the predicted. 43 minus 40 is 3. And then that's this little dot right there. That's the car that has a curb weight of 25.33 pounds, and its actual MPG is up here. And this residual that I just calculated, what it really is, it's the distance. It's the vertical distance. Oh, I didn't do that very well. It's the vertical distance being measured. There we go. That's better. The residual is this vertical distance being measured from the actual to the predicted line. All right, let me turn that red so you get to see that. So that's what that residual is. That 3 residual is the vertical distance between the actual and the predicted. The line is the dot is all my predicted values. The red dots are my actual values. And we repeated this whole thing for a curb weight of negative, of 27.79, right? Negative 1.53 times x, and the x value in this case is the curb weight, 27.79. Does somebody need something from me? Oh, you got it? Oh, hold on, I close the door. How you doing? Oh, okay. Hello. Hi. I'm doing a little recording. All right. Just someone came to say hi. All right. So, so I put in 27.79, 0.79, plus my y-intercept, 78.62, right? I'm trying to get a predicted value. Of course, I already have it on the screen. You see that already. I'm just showing you how we got this number, right? So we round into the nearest units. So it's 36 is the predicted. The actual was 30. We go back to the table to take a look at that, right? When we had a 27.79 curb weight, we had an actual observed value of 30, right? Actual was 30. The predicted was 36. 30 minus 36 is negative 6. That's the residual. That's the residual. And again, what is that measuring? It's measuring the vertical distance between, there we go. It's measuring the vertical distance between the observed dot and the line, right? And it's negative here because 30 is the observed. The predicted was much higher. 30 minus the predicted, it's a negative number. It's below the line because it's a negative number, and it's 6 below the line. All right, do I gotta get going? I gotta get going. So let's see. We found the predicted for each one of these. We found the residuals. Remember, each one is just the fuel. The residual is just the fuel efficiency minus the predicted. The observed minus the predicted gives us the residual. All right, and then we used our scatter plot, right, to find the residuals here. We placed our red dots on there. We used our calculator to do a residual plot. So I've already done the stat. Let me show you how to do that. Second, y equals stat plot. I am going to go to Y list here, and this time I'm going to turn it into resid. All right. So second, see how list is in blue here? I'm going to go to my list menu. It's second stat button is how to get there. And if you've done the regression, you have to do the regression in your calculator to get this. If you haven't done the regression, numbers, this resid option won't even show up. If I turn that into resid, all right, and then do zoom stat, I should get, there it is, a residual plot. See, that's the plot that's what we're plotting here. Right, there's my five dots, and there's my scatter plot with the line of best fit in there. Notice how the residual plot has the same kind of pattern as the scatter plot. And again, this residual is measuring these vertical distances between each one of those red dots and our blue line of best fit. All right. I still have a few minutes. So is there anything in here that we need to do? We're making a prediction. The predicted was actually pretty close to the actual. And we can say this residual plot here indicates that our line is a pretty decent fit for our data. We don't see any crazy pattern going on. It seems pretty scattered. Yeah. All right. Again, this is the scatter plot. We try to create a representation of the residual. Looking at this one, we'd say, okay, there's no pattern being formed. That means our data is going fairly, in the same direction. It's doing the same kind of thing as our model is predicting. Therefore, this is an appropriate model for this data, right? This scattered pattern in the residual plot tells me that my model is going in the same direction as my data. Therefore, good things. Therefore, the model is appropriate. Here's a situation where, here's our line of best fit, here's our data, and as you kind of notice, the data kind of is curved. And so I drew that red line in there so you kind of see that. And when we do the residual plot, we saw that curve as well. This curve tells us that there's another model that's a better fit than the linear in blue. And it's probably this red line, this curved red exponential thing going on, that's probably the better fit than our straight line linear. So this U shape here tells us the data is going in a slightly different pattern than our linear model would predict. We planted these 4 dots. We got a linear model. Let's see. I'm trying to see if there's anything funky in here because I got to get going. And we took these dots and we plotted the residual. So you enter this data into your calculator. This into list 1, this into list 2, find the predicted values based on the model that you've got, and then find the residuals. Remember, every time the residual is the actual minus the predicted, right? The actual minus the predicted is the residual. Complete your residual plot, use your calculator to do that, and then you're done. All right, I got to get going. Have a good day.